microwave oven? And we are going to see what are the modes we are going to use in this project, and what are the requirements for this project, and what is embedded system, which is most important for this project, what is microcontroller and microprocessor, and Pixim Lab, which is a development board we are going to use for this project, and CLCD, matrix keypad, ISR, timer, and finally we are going to see the demo of the project implementation. So first, what is microwave oven? Microwave oven is used to heat or cook the food using microwaves which use or form electromagnetic waves. There are several modes in various microwave ovens. We are going to implement four basic modes such as macro mode, grill mode, convection mode, and start mode. Let's see what are the working of these modes and how we are implementing it. First, what is macro mode? This is a traditional way of cooking mode. The maximum power of 900 watt will be consumed by this mode. In this case, the maximum time that user can use is up to 60 minutes. Next, the grill mode. Grill mode works as the macro mode, but its purpose is to cook the meat and bread. User can set the time as per the cooking time of meat or as per the requirement. Next, convection mode. In this mode, user can set the oven to preheat for a particular temperature for 3 minutes to preheat the oven. After preheating is done, user is asked to enter the time for their cooking. Next, what are the requirements for this project? Need some knowledge in embedded C and hands-on on embedded C, and we are going to use MPLab IDE to code for this project and use the XC8 compiler to compile this project. PiximLab board consists of many peripherals like a PIC16 F877A, 16 x 4 CLCD, tactile switches, matrix keypad, and timer. And some other peripherals are also used. Let's see in detail. Next, what is embedded system? Embedded system is a combination of any hardware and software which is intended to do a specific task. A general purpose system is used to perform large number of tasks, whereas an embedded system is used to perform a specific task. This is the difference between general purpose system and an embedded system. This is the embedded system block diagram where the embedded system consists of sensors, memory unit, control processing unit, hardware unit, and attenuators. Next, what are the types of embedded system? Standalone system, real-time system, network system, and mobile system. Let's see in detail about these systems and examples for each of the systems. First, what is standalone system? Standalone system is of two types, slave system and independent system. What is slave system? These systems are not intelligent even though they are embedded systems. The system cannot action by their own, cannot take action by their own. Example, semi-automatic washing machine. Second is independent system. These systems can take their action by their own. Example, Google car, which is a driverless car. They can drive by their own without any drivers or humans. Next, real-time systems. These systems are time-bound systems which will take action on a specified time. These are of three types: hard real-time systems, firm real-time systems, and soft real-time systems. In hard real-time systems, the system should meet the deadline. Any failures is not acceptable. Examples like such as light critical applications. Some real-time application is similar to hard real-time application but difference in economical properties. Soft real-time systems can have tolerance in meeting its deadline. Example for this real-time systems are airbag system. Next, network systems. What is network system? The system which are connected to a network like a Wi-Fi, Bluetooth, etc. are called a network system. Example, home system network, home security system. Next, mobile system. The embedded system which are movable are called mobile system. Example, robots. Next, this is the components of an embedded system which consists of a software and the microprocessors, these are the hardwares, microcontrollers, memory, ADC, DAC and so on. Let's see how to choose the embedded system. The embedded system should consume less power, the cost efficiency and processing power should be efficient, the system should be reliable, and the memory should be used efficiently. Next, what is microcontroller and microprocessor? An integrated circuit which is capable of being programmed to perform a specified task. It has a design restrictions such as the memory size, I/O capabilities, peripheral functions, etc. Choose a microcontroller based on applications, performance, price, availability of tools, and special capabilities. What is the difference between microcontroller and microprocessor? Let's see. In microcontroller, all components will be in a single chip. The flexibility is less, complexity is also less. In microprocessor, all components are assembled separately. Flexibility is more, but the design complexity is more. Let's get into the project peripherals. First, PixSimLab architecture. PixSimLab has a microcontroller PIC16F877A. We are going to use the buzzer and the matrix keeper, CLCD, and some other peripherals also used. These are the main peripherals in PixSimLab. Then syncing and sourcing circuit. What is syncing circuit and what is sourcing circuit? In the sourcing circuit, the microcontroller acts as an output for the at the microcontroller point of view. The microcontroller acting as input to the load, but it is acting as an output for the microcontroller. It is giving the current is flowing from the microcontroller to the load is called a sourcing circuit in which the microcontroller acts as a source to the load. Likewise, in this syncing circuit, the microcontroller acts as a load which consumes power from the 5-volt source. So this is syncing circuit. Next, CLCD. What is CLCD? CLCD is a character liquid crystal display which is used in this project. In PixSimLab, there are two types of display. One is a 16 cross 2 display and 16 cross 4 display. We are going to use 16 cross 4 display in this project. This displays the ASCII characters and some special characters. It is most commonly used to display. There are two types of communication modes, 4-bit mode and 8-bit mode. Here we are going to use 4-bit mode. Next, tactile switch. This is how the tactile switch looks, and this is pull down resistor circuit and pull up resistor circuit. In pull down resistor circuit, if the switch is open, then the controller will read 0. As the resistor is grounded, when the switch is open, the controller is connected to the resistor. If the switch is closed, the controller will read 1 as the controller will be connected to VDD as the switch is closed. In this pull-up resistor circuit, when switch is open, the controller will be connected to VDD and it will read 1 as. Then, if the switch is closed, the controller will read 0 as the switch is connected to the controller when it is closed. Next, what is the tactile switch? Tactile switch is a switch whose operation is perceptible by touch. The switch is used to select the mode of operation and to enter the time and temperature in our project. This switch will produce bouncing effect when we press the switch. MKP Matrix keypad. This is a keypad in which a number of tactile switches are connected in a row and column manner. This is used when more number of user inputs are required and still want to save some controller input-output lines. That is I/O lines. These keypads are most commonly used in telephone, digital keypads, digital lockers, calculators, etc. This is how the tactile kits are connected in our Pixim Lab software. Next, interrupts. What is interrupt? An interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the microprocessing unit or microcontrolling unit to stop the processing. Then the microprocessing unit or microcontrolling unit acknowledges the request and attends the request and go back to the processing where it was got interrupted. Next, what is polling? It is the process where the computer or controlling device waits for an external device to check the readiness or state, often with a low level hardware. Next, what are the disadvantages of polling method? Loss of events may occur when we use the polling method. Response will be poor. Power management will be less. What are the classification of interrupts? Interrupts are classified into hardware and software interrupts. Further, hardware interrupts are classified into non-maskable interrupts and maskable interrupts. These maskable hardware interrupts are further classified into external and internal. Next, ISR. What is ISR? ISR is an interrupt service routine. An ISR is a software that hardware invokes in response to an internet interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in ISR. It must be terminated with the instruction return instruction enable flag. When an interrupt occurs, the microprocessing unit completes the instruction being executed. Then it disables global interrupt enable, places the address from the program counter on the stack, and return from interrupt. Next, timers. Timers is an important application in any embedded system and default peripheral in a microcontroller which maintains the timing of an operation in a sync with the system time or an external time. It has many applications such as measuring time and generating delays, etc. Timers or counters is a software designed to count the time intervals between the events. There are four main terminologies in timers. Let's see one by one. First is resolution. It is also called register width, which is the width of a register. It may be 8-bit or 16-bit. Tick. Tick is referred as a change from one number to the another number while counting. It may be up count or down count. Quantum, which depends on the system clock, is a measure of time which is responsible for the tick. Next is the scaling. Scaling may be prescaler or postcard which is used to set the time as per our requirement. Modes of timers may be counter, pulse width modulation or pulse generator, etc. Let's get into the project demo. Let me open file is loaded and it's showing the 4 different modes of cooking, that is macro mode, grill mode, convection mode and start mode. When I click one to select the macro mode, it displays the screen asks user to enter the time required to cook the food. And after clicking the enter, that is hash, the cooler will start to run. After completing the time, the cooler will be turned off and the buzzer will be turned on to indicate us the cooking time is up. Let's see how it works. Let me click first a macro mode. It shows that the maximum power it consumes is 900 watt. It asks me to enter the time. Let me enter 5 seconds for our convenient. Let me enter hash. It shows 5 seconds. The cooler started running. After finishing, the buzzer will be turned on. I think you have heard that buzzer sound. Let me click a second cooking mode, which is the grill mode. It works as the macro mode, but its purpose is to cook meat or bread. Let me click a second grill. It is also asking me to enter the time. That is, I'll enter same 5 seconds. Convenient. Enter hash. See, the time is started and the cooler is also started. Buzzer will be turned off when cooking time is up. Next is the convection mode. When I click the third, that is convection mode, it asks the user to enter the temperature for which the oven should be preheated for 3 minutes. Let me click 3. It asks us to enter the temperature. Let me click 123 degrees Celsius and entered. See, the timer started with 180 seconds, that is 3 minutes. When the preheating is done, the buzzer will be turned on and it indicates that the preheating is done. Then the set time screen will be displayed where we should set the time to cook the food. Meanwhile, I'll explain this. I told that PixinLab has two types of CLCD, that is 16 cross 2 and 16 cross 4. We are using 16 cross 4. These are the tactile switches which are connected in row and column manner, which constitute a matrix keypad. These are the LEDs. This is the microcontroller, and in this case, we'll see how the starter resume work pass. When we click pause, how it works, and when we click stop, how it will work. Let's see them. Let's wait for a few more seconds. And this is the RB3 switch which we are using to open the door. When I open the door, the CLCD will display that the door is open, please close the door. And the buzzer will be indicated, the buzzer will be turned on and indicates that the door is open, please close the door. And I will show that how it works. Preheating is going to be done. See, the CLCD is displaying and asking us to enter the time to cook the food. Let me enter 20 seconds to show how other options work. Let me enter. And you can increase the time by pressing start, that is a 4 key. And you can pass by pressing 5. See, I have pressed the 5. The motor, the cooler is stopped. When I press 4, it will get resume, and now it will not get increased by 30 seconds. It will resume where it got stopped. Let us see that. I am entering 4. See, it is not incrementing by 30 seconds. And I can stop by pressing 6. And when I press RB3, the door will be opened, and the buzzer will be turned on, and CLCD displays that a door is open. Please close the door. Let us check that. See, I will open the door. I hope you have heard that buzzer sound and the screen displayed. You can stop by pressing 6. See, the cooking mode screen is visible. You can use the fourth option, start mode, to cook, to heat any food or to cook simple foods. When I click for 4, it automatically starts with 30 seconds. You can increase the time by clicking 4. Let us see. I'll click 4. See, it has started from 30 seconds. You can increase the time by clicking again 4. See, the time is incremented, and you can pass by pressing 5. See, all are stopped. Let me resume by pressing 4. Now the time is not incremented when I press the switch 4. When the time is completed, the cooler will be off and the buzzer will be turned on, indicating that the cooking time is up. Let's see. This is all about our project. This internship is very useful for me to learn many things like embedded C, about a microcontroller usage, and how to use it in an real-time applications, etc. Let us wait for 10 more seconds. I hope you have seen the screen that cooking time is up and you have heard the buzzer sound. This is all about our project.